Hi, hello, welcome to the final presentation for my CP3202 Internship program. So first, let me give you an overview of this whole presentation. So actually, in the past 3 months, I worked as a software engineer intern at Hello Technology. The project that I'm working on is actually a single sign-on system, which is short as SSO. So I design, develop, and deploy this system to replace the login mechanism of a few web applications. In particular, Redis cluster is a very important component of this system. It's actually used as a distributed cache to ensure that this system has high availability and it also has horizontal scalability. So this is about authentication and authorization, and Redis cluster will be a key style that we are going to talk about later or more. So what is SSO? Or what is single sign-on? Usually or traditionally, people need to log in separately for each website. Let's say that they are deployed under different domains. So actually this is because HTTP protocol itself is state-based. So any login, in order to maintain the state of the users, they need to rely on cookie and session. Cookie cannot be shared between different domains. This is due to some security concerns. Of course, if one website can access cookie of another website, it's very insecure. This is actually called same origin policy. But let's say I'm the user of one of your products, but actually I want to use more products, or I'm the user of your multiple products. I need to log in. So to make a better user experience, of course, we hope that the user only need to enter the username and password once, then they can gain access to a few independent but yet somehow relevant systems. That is single sign-on. Particularly in this project that I have been working on in the past 3 months, we actually redirect all the login requests to a centralized login website. And this login website will handle all the login mechanism and the backend logic. When the user enters the username and password, it will validate against the ADAPT servers. If they match, it will return the successful authentication result. Otherwise, it will return a failure result. We are actually using the Central Authentication Service Protocol, which is short as CAS. CAS is a very famous SSO protocol that is initially developed at Yale University, although now it's under a parallel organization, which is actually a non-profit foundation. So here is the architectural diagram for this system. As you can see, let's say from the left part, on the left-hand side, in the green area, there are 3 web applications. So SSO are enabled for these 3 web applications. So when you ever log in, your login will be redirected to the login server or the login website, which is the actual SSO system on the right. So in the yellow area, you will see that the load balancer will direct your login traffic to one of the Tomcat servers. And when the Tomcat server tries to validate the username and password to see whether they match or not, the ticket itself, which is later something we need to talk about, they will be stored in 6 Redis cluster nodes. So some of them are master nodes, some of them are slave nodes. So we will also elaborate more on the master and slave model later. So they will validate the username and password against different LDAP servers. LDAP stands for Lightweight Directory Access Protocol. And then they will, in the end, they will return the result to one of the 3 web applications with SSO enabled to tell you whether you can log in or you cannot log in. So actually, this SSO system includes the following components. The Nginx server is a load balancer for the SSO system. Tomcat will be used as the web application server. And Redis is a NoSQL database, which actually also a distributed key value store cache. So LDAP server is a directory server, which is actually kind of like a database, but it's much faster at read, which is perfect for our case because login is much more frequent than SAP. So now let's talk more about this Redis cluster. So at its core, this single sign-on system needs to maintain user state, but there are a lot of users. It's better we do not store all the user information in memory. We need some persistent layer. Here we are using Redis cluster. Redis itself is a popular NoSQL database, which is also a key value cache. And Redis cluster is the official recommendation, the recommended method to do horizontal partitioning if your dataset in Redis is too huge. So Redis cluster provides two very important features. One of them is called data sharding. Data sharding is actually another name for horizontal partitioning. It partitions a very large dataset into smaller, which is also more easy for us to maintain to manage parts. Another key feature is master-slave failover. So each master node has a few slave nodes. Actually, they are the backups for the master. So they always keep sync with the master nodes. When the master die or when the master fail or the master have some failure, you cannot access it. One of the master's slave nodes will be promoted, and the slave node being promoted will become the new master node to replace the failure one. Thanks to these two very useful features, we ensure two properties of the SSO system: high availability and horizontal scalability. They are also two important fundamental features of a distributed system. High availability means that your system can still survive under disaster condition. Let's say some of the hardware fails, you just cannot access it. And another property is that horizontal scalability. You are able to handle a large amount of traffic concurrently, so that I can serve a lot of users. This is especially important because now all the login traffic have been directed to this centralized login website. They must be able to handle this large amount of traffic. In summary, I learned a lot from this 3-month internship. Of course, I learned the mechanism of a few popular SSO protocols, such as the one that we are using currently, CAS, also like OAuth or SAML, which stands for Security Markup Language. Of course, learn some fundamental designs of distributed system. In particular, now at this project, it's Redis and Redis cluster. They help a lot when you dataset or when your traffic grows. I certainly improve my programming skills in Java because the whole system, the whole SSO system, are built and coded in Java. Apart from the technical content, I also learned a lot of non-technical aspects as well. First, I gained some industry experience in software engineering. Also, I learned and improved my verbal and written communication skills, which is also important. I really know what I should do after my graduation as well. So that's all for my presentation. Thank you very much.